So we are done with ratio and proportion, and now we are going to start with indices. The definition in simple terms, that's in layman language, is just an easier way to represent very big numbers. For example, we have a number like 729, so it can always be represented by a small number to the power of something. So a small number like 3 to the power 6 would also give you 729, is just another way of representing a big number. So 3 to the power 6 would be called representing it in the form of indices. Similarly, 8 could be represented in the form of 2 to the power 3. So these are various ways of representing indices. Now, terms, as we read that everywhere we have specific terms, specific words for terms like antecedent, consequent. Similarly, in indices, if you have a number where it's written as a to the power n, so here a represents the base of the number, whereas n represents the power or the index. So when we say 729 is equal to 3 to the power 6, 3 represents the base and 6 represents the power or the index. So if we have an elaborated form of a to the power n, it means that it is actually a into a into a into a to n times. So when we were talking about 729 could be represented at 3 to the power 6, what we mean is that it is actually product of 3 6 times. That is 3 into 3 into 3 into 3 into 3 into 3. That means 3 has to be written 6 times. So it is a way of actually writing a very big number. So all we understand is whenever we have something like a to the power n, it means that actually it is a into a into a n times. Okay. Now we'll move on to other laws of indices. You really need to remember this if your base is not very strong. But in case you have a very good mathematical base, I'm sure you must be knowing all this because we use these very often. In almost, I guess, every chapter we tend to use these. So these are very basic laws of indices. Any base when raised to the power 0 will be equal to 1. So if I say that a to the power 0 and we ask the value, it would be equal to 1. Right? So if you have 3 to the power 0, that is not equal to 3. It is actually equal to 1. 3 to the power 1 is equal to 3, but 3 to the power 0 is equal to 1. Then we have another thing, another law which states that if we have something like a raised to the power m into a raised to the power n. So here both the bases are equal, it's just the powers which are different and they have been multiplied, right? So that means we have a product. So here this would be equal to a to the power m plus n. So if the bases are equal and we have a product of the numbers, then the base would remain the same and the powers could be added. So please remember this, that a to the power m into a to the power n is equal to a to the power m plus n. So if we have something like 3 to the power, if we have something like 3 to the power 2 into 3 to the power 3, so we can always write it as 3 to the power 2 plus 3 or 3 to the power 5. Okay? Please remember these small things. It's not this that if you have something like a to the power m plus a to the power n, so that would be equal to a to the power mn. Please remember these. It is actually a to the power m into a to the power n is equal to a to the power m plus n. It may sound funny to you all, but I'm telling you all it's a very common mistake which many people tend to do. When they see something like 3 to the power 2 plus 3 to the power 3, they start, okay, this is 3 to the power 2 plus 3, or they'll start like 3 to the power 2 into 3. Please, this rule only applies when it is 3 to the power 2 into 3 to the power 3. Okay? Yeah. The next law which states if we have something like a raised to the power m divided by a raised to the power n, we can write this as a raised to the power m minus n. So if there's a division between two numbers, we can have the subtraction of the powers. Okay, the base remains the same. Then the third law is if we have something like a to the power m whole into raised to the power n, So this can be written as a to the power mn. So both the powers can be multiplied. Then another thing is, if you have ab raised to the power n, that means you have two numbers which are products and you have them raised to the power n, the n could go and get multiplied with, go and be raised to the power of every particular number. So it will be a to the power n into b to the power n. Another thing, a to the power minus m, this can be written as 1 by a to the power m. Similarly, if it's 1 by a to the power minus m, it can be written as a to the power m. Now, if ever you have something like, if a to the power x is equal to a to the power y, so please remember, if both the bases are same, both the bases are equal and they say that both are equivalent, so this is only possible if x is equal to y. Okay. Another one is, if x to the power a is equal to y to the power a, so even then you need to remember that x would be equal to y. Is it okay? We'll have a quick recap of this so that you have a very good hold on it. Let's see. So if we have something like, we have something like a to the power m into a to the power n. So this could be written as a to the power m plus n. Okay. So we'll take it with a small example. If 3 to the power 2 into 3 to the power 3 is given to you. So please remember, this can be written as 3 to the power 2 plus 3, which is 3 to the power 5. See, only thing which I want to make sure is, please remember, if you have a question like 3 to the power 2 plus 3 to the power 3, please don't write this as 3 to the power 2 plus 3. This is completely wrong. Okay. Please remember that this applies only when you have a to the power m into a to the power n and both bases are equal and we have two different powers, they can be added. Okay. Similarly, we have something like, if we have a to the power m divided by a to the power n, so this can be written as a to the power m minus n. Right? So if we have something like 3 to the power 3 divided by 3 to the power 2, you can always write this as 3 to the power 3 minus 2, which is equal to 3 to the power 1, which is equal to 3 answer. I'm again writing this for you. Please remember that there should be nothing like, if we have something like 3 to the power 3 to the power 3 minus 3 to the power 2, this cannot be written as 3 to the power 3 by 2. This is wrong. Okay. Another property which we did was, if we have something like a to the power minus m, this is actually equal to 1 by a to the power m. Okay. Please remember this. This is a very important property. You will be needing this very often. Okay. So if you have something like 3 to the power minus 4, this can be actually written as 1 by 3 to the power, okay, which is 1 by 81. Okay. I hope this is clear. So these were three properties which we did. Then what else did we do? We did was a to the power m into n. Okay. So this is a to the power m to the power n. So if we have something like this, we can multiply and we can write a to the power mn. So if you have something like 3 to the power 3 whole to the power 4, this can be written as 3 to the power 12. Remember this, it sometimes becomes very confusing and you start thinking, I don't know what. Don't get confused by if you have something like 3 to the power 3 to the power 4. So this is different. This is 3 to the power 81. Okay. But here we are talking about something like 3 to the power 3 whole to the power 4. So this would be 3 to the power 12. Okay. I think these are very important properties. That's all. Other things, even if you miss out on, it's okay, but please, these are four important properties. Please remember, they will be required for solving all questions. Okay. So that was all on theory with ratio, proportion, and indices. We'll take up more questions now. And see, as in the exam hall, you really don't know whether it's a question from ratio or proportion or indices or simple interest. Similarly, they don't give you like it's a topic from this. Similarly, now we'll handle questions randomly. Maybe they'll be from ratio or proportion or indices. And we'll just solve them thinking it's just an exam question. Okay. So MCQ number 26, it says if A is to B is equal to 4 is to 1, then find out the value of root over of A by B plus root over of B by A. See the question once, and we'll just try solving this mentally. See, as ever I tell you that take the common ratio as x, so it would be A is 4x, B is x. So we'll just substitute. So what happens is, instead of A it's 4x, instead of B it's x and x is getting cancelled. So you have root over of 4, which would give you 2. Correct? In the second part, it's root over of B by A, so it will give you root over of x by 4x. So it will be 1 by 4, which would give you 1 by 2. So the thing is 2 plus 1 by 2, which is 2.5, or you can also say it's equal to 5 by 2. Let's just find out options, check out the options. The first option says it's 5 by 2, which is 2.5, which you already got. So that's the correct answer. So please mark 26A. Okay. Now another thing, when you have a question which has root over, you always know that you could always have a positive value to it also and a negative value. So the first part could give you 2 also, and it could give you minus 2 also. So I request you to please check other options also, in case they also have anything related to the minus part of it. Then maybe you could be in trouble. So always check out another options also. Second option is 4, the third option is 5, which has nowhere any relation to what we were talking of. So the answer is 5 by, okay. We'll solve this on board also. So the question was A is to B is equal to 4 is to 1. So we took it as what common ratio is x. So A is equal to 4x, B is equal to x. We have to find out the value of root over of A by B plus root over of B by A. I'm just writing this. This would be equal to root over of 4x by x plus root over of x by 4x. I'm just cancelling out x and x, and here also x and x. So it's giving me 2 plus half, which is 2.5. 5 by 2. This is the answer, which was option A. Correct? Take your time, understand it. But I would always prefer, as ever, that you all solve it mentally. It's very simple to solve things mentally. It takes really less of time. Okay? So option A is the correct answer. Now the next question. The next question is 4x to the power minus 1 by 4. You remember I just told you, if we have something like a to the power minus m, that can be written as 1 by a to the power m. Right? So here if we have something like x to the power minus 1 by 4, it can be written as 1 by x to the power 1 by 4. So this can be written as 4 by x to the power 1 by 4, which is option C. Correct? Right? I'll just show it to you also what we are talking about here. We just said that if we have something like a to the power minus m, it could be written as 1 by a to the power m. So in the question we have something like 4 into x to the power minus 1 by 4. This can be written as 4 into 1 by x to the power 1 by 4, which is equal to 4 by x to the power 1 by 4, which is option C. Right? So the answer is option C, 4 by x to the power 1 by 4. Okay? So the next question is, the value of 4 by 32 to the power 1 by 5 is. Okay? So I'm not sure if you can get a click of it so soon, but 32 could be written as 2 to the power 5, right? So this can be written as 2 to the power 5 whole to the power 1 by 5. You should get a clue when you have something like whole to the power 1 by 5. So you should know that inside also some multiple of 5 would only come in, only then it could get cancelled. Okay, so 4 divided by 2 to the power 5 whole to the power 1 by 5. We just said that if we have something like a to the power m into n, I mean bracket to the power n, so it can be written as a to the power mn. So here also it will get multiplied. So 2 to the power 5 into 1 by 5. 5 and 5 will get cancelled. So you'll remain with only 2. 4 by 2, which is 2. So the option would be option B. Correct? We'll solve this, don't worry. So what the question states is, it's 4 by 32 to the power 1 by 5. 4 by 32 to the power 1 by 5. So this can be written as 4 by 2 to the power 5 into 1 by 5. Right? So we just said that if you have something like a to the power m whole to the power n, so this can be written as a to the power mn. So we're going to apply the same thing. It can be written as 4 by 2 to the power 5 into 1 by 5. This can be written as 4 by 2 to the power 5 into 1 by 5. So this is 4 by 2, which is equal to 2. Correct? Right? So this matches our option C, which is the answer. Correct? Just remember the basic 3, I told you all, please remember the basic 4 laws. It's very simple. A to the power m into a to the power n is equal to a to the power m plus n. A to the power m by a to the power n is a to the power m minus n. A to the power m whole n is equal to a to the power mn. And a to the power minus m is equal to 1 by a to the power m. I'm just repeating this so that it just, registers in your mind. It's just there. Okay? Let's move on to the next question. So our next question is, if x to the power 1 by p is equal to y to the power 1 by q is equal to z to the power 1 by r and xyz is equal to 1, then find out the value of p plus q plus r. Okay? Take a minute, please read the question again. It says, if x to the power 1 by p is equal to y to the power 1 by q is equal to z to the power 1 by r and xyz is equal to 1, then find out the value of p plus q plus r. Okay? We'll solve the question. So the question says that x to the power 1 by p is equal to y to the power 1 by q is equal to z to the power 1 by r. Okay? So let this is equal to k. Fair enough? So we can say that x to the power 1 by p is equal to k, or see, suppose you take pth power to both the sides, so you can write this as x to the power 1 by p to the power p is equal to k to the power p, or this can be written as x is equal to k to the power p. Agreed? Similarly, y would be equal to k to the power q, z would be equal to k to the power r. Agreed? See, just check it out. So if we have something like x to the power 1 by p is equal to k, so what we are doing is we are taking the pth power on both the sides. So it will be x to the power 1 by p into p is equal to k to the power p. So we just read a to the power m into n is equal to a mn, right? So you can write this as x to the power 1 by p into p, which is x to the power 1, which is x, right? So you can write this as x is equal to k to the power p. Very similarly, if you take y to the power 1 by q is equal to k, so then again you will take the pth power and you can find out that it will come to y is equal to k to the power q, z is equal to k to the power r. Agreed? In the question, it says that PQR is equal, XYZ is equal to, it says XYZ is equal to 1, right? So I'm just substituting the values of x, y and z, which can be written as k to the power p into k to the power q into k to the power r is equal to 1. Correct? So we just read that a to the power m into a to the power n is equal to a to the power m plus n. Right? So similarly, we can write this as k to the power p plus q plus r is equal to 1. Agreed? Right? Because it's k to the power p into k to the power q into k to the power r. So this can be written as k to the power p plus q plus r, which is equal to 1. Correct? So we also know that anything would yield 1 if it's to the power 0, right? So k to the power 0 would be equal to 1. So this can be written as k to the power p plus q plus r is equal to k to the power 0. Correct? Or we can write that p plus q plus r is equal to 0. How can we write this? This is because we just know that if both the bases are equal and both the terms give equivalent amount, so we can say that the powers are also equal. You remember our last law? So p plus q plus r is equal to 0, which is a part of your options. See, what I want to tell you all is that there were 4 important things which we really studied in this question. First, we've used the law that anything raised to the power 0 would yield 1. Right? So that is what we've done here. We just checked out that we just wrote that k to the power 0 is equal to 1. So please remember this. This is an important law. Another thing was a to the power m into a to the power n would yield a to the power m plus n, which we've used here. We've written that k p into k to the power q into k to the power r is equal to k to the power p plus q plus r. Right? Similarly, what else did we use? Another thing which we used was if both the bases are equal and they give equivalent amount, then we can say that the powers of both the terms are also equal, which we've used here. K, p plus q plus r is equal to k to the power 0. So since both the bases are equal, so we've said that both the bases are equal and both the terms yield the same thing. So we can say that the powers have to be equal. So p plus q plus r is equal to 0. Right? Seeing such questions, all you need to remember is that I always told you all that if you all don't get any answer, just remember, without thinking, just take it equivalent to some variable. So here that is what we did, a constant. So here that is what we did. X to the power 1 by p is equal to y to the power 1 by q is equal to z to the power 1 by r. We took that as equal to k. And then we could easily solve the question taking the pth power and everything. And then we got the answer as p plus q plus r is equal to 0. Correct? The only thing which is very simple is you have another way out, which is when you have something like x, y, z is equal to 1, you need to just substitute the values. That's what we did here. In place of x, we did k to the power p. In place of y, we did k to the power q. In place of z, we did k to the power r. See, have a look at the question again and the answer. This is a very typical kind of a problem and very different from whatever we've done earlier. Okay? So, the answer stands as p plus q plus r is equal to 0. Now, let's move on to the next question. MCQ 30. If x by b plus c minus a is equal to y by c plus a minus b is equal to z by a plus b minus c, then find the value of b minus c into x plus c minus a into y plus a minus b into z. So, you can just see the question once. The first thing is, if we have something like where it says that there are three particular variables which are equal, we should always think as the first step to be is equal to k. So always take it as equal to k and then take a long method. Probably it will take some time to solve. You can just solve this and then place the values of x in the equation given and you can find out the value of the particular thing which is required. Another thing is, just look at the options once. We'll always solve this. I would always tell you all, obviously solve such questions. But it's just this, that when you have questions like this, it's very obvious that in these questions, everything is going to get almost cancelled. If it's very visible to you. Because see, bx minus cx plus cy minus ay plus az minus bz. I'm just opening the brackets. So then when you place the values, you will almost realize that always things get cancelled here and the answer will maximum time be 0. When you have questions like such complicated questions. So if you want to take a risk and if you have a lot of time to save, in case you all have very less time and you all really need to answer, so then you can go for in maximum times it's going to be 0, but just look at it that things are getting cancelled or not. But yeah, it will hardly take you 2 minutes to solve. So obviously try and solve the question also. We'll solve this. X by b plus c minus a is equal to y by c plus a minus b is equal to z by a plus b minus c. So this is the question. Let this is equal to k. Okay. So what is the value of x? X is equal to kb plus kc minus ka. Okay. We'll always keep k as the first term and then we'll keep any other term so that we never get confused. Then y is equal to kc plus ka minus kb. Okay. And z is equal to ka plus kb minus kc. Perfect. Then now the value we have to find out is for, I'm just opening the bracket. The value is supposed to be found out of bx minus cx plus cy minus ay plus az minus bz. Right? This is what we are supposed to find out. Okay. So I'll just quickly find out the values of all of these. See, it will be easier if I find out the values of bx first. So the value of bx is going to be what? I'm going to place the values here. Okay. So find out the value of bx. See, for bx what we need to do is just multiply this by what? B. So quickly let's do this. So it will be kb square, right, plus kbc minus kab. Correct? Then we have to find out the value of cx, right? So minus cx. So minus of what? Cx. So multiply this by c now. So it will be minus kbc plus kc square minus kac. Okay. Then we need to find out the value of cy. So which will be what? This multiplied by c. So it will be kc square plus kac minus kbc. Okay. Then you have to find out the value of ay. So multiply this by a. So minus ay. So this will be kac plus ka square minus kab. Okay. Then we have to find out the value of az. So multiply this by a. So this will be plus ka square plus kab minus kac. Right? Minus bz. So this will be minus bz. So multiply this by b. So it will be kab plus kb square minus kbc. Right? Agreed? Now what you're going to do is we're just going to open the brackets and put the values at this place. So the values are for bx, we are just opening the bracket, okay? So it will be kb square plus kbc minus kab minus kbc minus kc square plus kac plus kc square plus kac plus kbc minus kac minus ka square plus kab plus ka square plus kab minus kac minus kab minus kb square plus kbc. Agreed? So let's start cancelling. See, plus kb square minus kb square gets cancelled. Another we have is plus kbc minus kbc gets cancelled. Minus kab plus kab gets cancelled. Minus kc square plus kc square gets cancelled. Plus kac minus kac gets cancelled. plus KAC minus KAC gets cancelled, plus KBC minus plus KBC. We need to just check this if this is correct or not. This is the first line. Yeah, so let's just check. KB square plus KBC minus KAB minus KBC minus KC square plus KAC plus KC square plus KAC minus KBC, right? So this will be minus KBC. So minus KBC plus KBC gets cancelled, minus KA square plus KA square gets cancelled, plus KAB minus KAB gets cancelled. So the answer stands as 0. Right? So the answer is 0. I told you all initially also in the first step, just try and see this. Almost you'll understand that whenever there is no division, right? Just because here the value has to be found out of something which is in a single way, just a numerator. There is nothing called division. So there is no division. Almost in such cases, all the values get cancelled and you get an answer as 0. If you're willing to take a risk, take a risk. Otherwise, obviously you can solve this. I was dictating and solving it. In case you all try and solve this on pen, just by yourselves, I'm sure you will not take more than 2 minutes. So do it as fast as possible and you'll get the answer. So the answer stands as B, 0. Take a minute, you can always see this again. Next question, MCQ 31. If A cube minus B cube is equal to A minus B into A square plus AB plus B square, then find out the simplified form of x to the power L by x to the power M whole to the power L square plus LM plus M square into x to the power M by x to the power N whole to the power M square plus NM plus N square into x to the power N by x to the power L whole into L square plus Ln plus N square. See, here they have at least given you this information that A cube minus B cube is equal to A minus B into A square plus AB plus B square. I can tell you with 100% guarantee in the exam hall they are not going to give you this formula. They expect you to know these things. So please remember the basic arithmetics formula. A cube minus B cube is equal to A minus B into A square plus AB plus B square. In the algebra formulas these are expected to be known. Then we have another thing like A cube plus B cube is equal to A plus B into A square minus AB plus B square. So these are very basic things which I hope that you all will remember. Okay. Now let's just solve this. This is a very simple question. A very small simplification is required. You can see that it's written L square plus LM plus M square. When you just check it out with A square plus AB plus B square, you can always relate to it and understand that it is related to A square plus AB plus B square. Okay. Let's solve the question. So the question says A cube minus B cube is equal to A minus B into A square plus AB plus B square. Let's just write this as, L cube minus M cube is equal to what? L minus M into L square plus M square plus LM. Right? So if I want to find out the value of L square plus M square plus LM, this will be equal to L cube minus M cube divided by L minus M. Correct? Similarly, I can write that also M square plus Mn plus N square would be equal to what? M cube minus N cube by M minus N. Right? Also I can write that L square plus Ln plus N square would be equal to L cube minus N cube by L minus N. Agreed? Right? Now let's find out the value. Okay? x to the power L by x to the power m whole to the power L square plus Lm plus m square into x to the power m by x to the power n whole to the power m square plus mn plus n square into x to the power n by x to the power l whole to the power l square plus ln plus m square. Agreed? See, just check out on one thing, that here they have n in the numerator and l in the denominator, right? So here when we have something written like l square plus ln plus n square, so because n is in the numerator, just change this, okay? Make this into n square plus nn plus l square. It will be easier, otherwise you will have some complication later, okay? So similarly there also we will change, but let's proceed with this, then we will try and understand. If there is a problem, we'll resort to it, okay? So move on. What you can write this as x to the power L minus m. You remember, a to the power n by a to the power m is actually equal to a to the power n minus m. Okay, I will go with the same variables. If you remember in our first class of indices, we had discussed that x to the power a by x to the power b is equal to x to the power a minus b. So we are using that same formula here. X to the power l by x to the power m is actually equal to x to the power l minus m, right? So we can write this as x to the power l minus m. We just wrote that l square plus lm plus m square is equal to what? L cube minus m cube divided by l minus m, right? We just found out. Similarly, you can write that x to the power m by x to the power n is actually equal to x to the power m minus n, right? Whole into m square plus mn plus n square can be written as what? M cube minus n cube by m minus n. Agreed? Similarly, for x to the power n by x to the power l, what can you write? Can be written as x to the power n minus l whole into, see, again we will place this as what? Let's write this as n square plus nl plus l square. Similarly, if you put it there in that formula, then you understand that this can be n cube minus l cube by n minus n, right? So let's write this as n cube minus l cube by n minus n. Doesn't make sense going into any complication, writing it as L cube minus N cube and then again 1 divided by this and then cancelling. All that stuff is not required. It's always easier to write it like that. I'll show it to you if you want to keep it as same also. But first let's just solve this in the simplest possible way. Let's just cancel L minus L, L minus M, M minus N, M minus N, N minus L, N minus N. Correct? So this can be written as x to the power L cube minus m cube into x to the power m cube minus n cube into x to the power n cube minus l cube. Agreed? Now, first class, what was the formula? X to the power a into x to the power b is equal to x to the power a plus b. Please remember again the same thing I am saying. X to the power a plus x to the power b is not equal to x to the power ab. Please remember this. So here what is it? It's actually products only. So what we can do is we can just add the powers, right? So this can be written as x to the power L cube minus m cube plus m cube minus n cube plus n cube minus L cube. Correct? Since x to the power a into x to the power b is equal to x to the power a plus b. Agreed? Now let's just cancel L cube, M cube, N cube, N cube, right? If everything gets cancelled, what is it? It is 0. Please don't get confused and say that this is equal to 1. This is actually equal to 0. So x to the power 0, which is equal to 1, and this is the answer, right? There are some people who believe if everything gets cancelled, it is actually equal to 1. No, please, it's actually equal to 0. When you have something in a divisional form, which is x to the power a by x to the power a, if these two get cancelled, then it is 1. Okay. So suppose if you would have written it as 1, then you would have got x as the answer, which would be one of the options, and then your answer would be wrong. So please remember, if everything gets cancelled, it is actually equal to 0. You must be finding it dumb, but there are some people who actually feel like that. So that's why I'm just making sure that every concept is clear. So you get this equal to 0. So x to the power 0 is equal to 1, and that is the answer. Correct? Right? Now just for those people who believe that, suppose if I had already taken it as L cube minus N cube only, in this place, if I would have taken, in this place, if I had this as L by N only, then what would I do, right? Because initially we had actually taken it as what? We had found out the value of L square plus Ln plus N square only. This thing only we had found out the value. So if this was the case, then what would have happened? We'll just solve it like that, okay? So that you don't feel that how would I come to know that's N, L and all that, okay? So let's solve it like that also. So this would be what? X to the power L by x to the power m whole to the power L square plus Lm plus m square into x to the power m by x to the power n mn plus m square plus n square into x to the power n by x to the power L into L square plus Ln plus n square. Agreed? So we'll just put the values, quickly put the values. See, all these values you already know, okay? So I'm just putting this very easily, x to the power L minus m into L square plus Lm plus m square. We already did this, into x to the power m minus n into mn plus m square plus n square. For this part, what would it be? X to the power n minus L into L square plus Ln plus n square. Agreed? Right? So what would this be? This, we similarly as we did, we got this cancelled and we got L cube minus M cube. Right? Then we had this, so we got x to the power M cube minus N cube. For this part, what is going to be the case? X to the power N minus L into, you wrote it as what? In the previous question, you wrote it as L cube minus N cube by L minus N. Right? So you would take minus common, so this would be N minus L. Right? Now you would get this cancelled. This minus would go get multiplied with this. So we would get this as x to the power n cube minus L cube. Agreed? So again this would be the same thing then. X to the power L cube minus m cube plus m cube minus n cube plus n cube minus L cube. Everything would get cancelled and would be x to the power 0, which is equal to 1 as the answer. Okay? So I'm just making sure that whatever you've done, there will be some method out. It's not just that you need to see the question and then accordingly find out the value, but just be fast at it. Okay? Done? The next question is x to the power a by x to the power b whole to the power a plus b into x to the power b by x to the power c whole into b plus c into x to the power c by x to the power a whole into c plus a. Find out the value of this. Okay? So let's on very similar grounds only what we did earlier, but in the earlier question we were using L cube minus M cube. So that's why, you know, I told you all that be 100% sure that the institute will not give you the formula written and it will not be a piece of cake that you can just apply it as in the previous question. Obviously you need to remember certain algebraic formulas which we've studied in the earlier classes. Quick recap, I'll just go for it. Remember a cube minus b cube is equal to a minus b into a square plus ab plus b square. A cube plus b cube is equal to a plus b into a square minus ab plus b square. A plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. Remember, a minus b is equal to a minus b into a plus b is equal to a square minus b square. So these are 5 very basic formulas which you really need to remember. Otherwise I'm telling you all, you will be in trouble. You will not be able to solve the questions. And they're not going to give you anything written like if this is the formula then find out this. They will not give you such an easy question. Okay. So remember these 5 basic algebraic formulas and then it will be very easy for you all to solve this question. So let's solve this. So the question is x to the power a by x to the power b whole to the power a plus b into x to the power b by x to the power c whole to the power b plus c into x to the power c by x to the power a whole into c plus a. Okay, so let's continue. X to the power a by x to the power b is x to the power a minus b whole into a plus b into x to the power b minus c into b plus c into x to the power c minus a into c plus a. Right? Agreed? I just told you all a minus b into a plus b is what? A square minus b square. So applying a minus b into a plus b is equal to a square minus b square. We get, let's put this as x to the power a square minus b square into x to the power b square minus c square into x to the power c square minus a square. Agreed? So what is the formula for x to the power a into x to the power b? That is x to the power a plus b. Right? Correct? So we'll apply that. This is equal to x to the power a square minus b square plus b square minus c square plus c square minus a square. Since x to the power a into x to the power b is equal to x to the power a plus b. Agreed? Let's cancel. A square gets cancelled, b square gets cancelled, c square gets cancelled. So this is equal to x to the power 0. What is the value of x to the power 0? 1, which is option A. Agreed? Right? So just remember, see, you can always see that the very basic formula like x to the power a into x to the power b is equal to x to the power a plus b. This is being used way lot of times, and x to the power a by x to the power b is x to the power a minus b. Right? We did it and the answer comes as 1. Next question, MCQ 33. The question is, if a to the power x is equal to b, b to the power y is equal to c, c to the power z is equal to a, then find out the value of x, y, z. Okay? Let's see, I'll give you all two methods of solving this. One, in case you've studied logarithms, then we'll do it by log. And another thing is, you can always solve it by the indices method also. So we'll solve it by both methods. First, because we are doing a part of indices itself, so let's solve it by the indices method. And then we can always have logarithms also. Okay? So it is a to the power x is equal to b, b to the power y is equal to c, c to the power z is equal to a. Right? So let's first put the value of b here. So what is the question is b to the power y is equal to c. So in place of b, we'll put the value as a to the power x. So this can be written as what? A to the power x into y is equal to c. So this can be written as a to the power xy is equal to c. Agreed? Again, in place of a, we can put it as c to the power z. So we'll put c to the power z is into x to the power y is equal to c. See, I'll just write now. Since b is equal to a to the power x, so I'm putting this value here. Since a is equal to c to the power z. Okay? So this comes as c to the power xyz is equal to c to the power 1. Agreed? See, both the bases are equal. If you remember in the first class we did, if x to the power a is equal to x to the power b, then a is equal to b. The perfect law of indices. Right? We had done this as probably the 7th or the 8th law. So just revise the laws. Okay? So now, therefore, xyz is equal to 1. Since x to the power a is equal to x to the power b, if x to the power a is equal to, then a is equal to b. Agreed? So we have this as option A. So this is option A, which is the answer. Second method, we will solve this by logarithms also. Okay, I'll just write a second method. See, what it says is a to the power x is equal to b, b to the power y is equal to c, c to the power z is equal to a, right? So let's just take log. So taking log on both sides, so what will you get? Log ax is equal to b. So this can be written as x log a is equal to b, log b, sorry. Right? So therefore x is equal to log b by log a. Agreed? Similarly, if you take log on both sides for these two also, you will get y is equal to log c by log b. Here you will get z is equal to log a by log c. Agreed? Right? You all know this, right? That if you have something like log a to the power n, so which is equal to n log a. Correct? So this is since if log a to the power, log a to the power n is equal to n log a. Right? This is because of this formula. What do we have to find out? We have to find out the value of x, y, z. We will just substitute the values. In place of x, we will write log b by log a into, in place of y, we will write log c by log b. In place of this, we will write log a by log c. Correct? We will cancel log c, log c, log b, log a, which is equal to 1, which is option A, answer. So whatever strikes first is going to be the perfect choice for you. Both will take almost similar time. So there's nothing like this is going to take extra time or that's going to take extra time. It's just what strikes you first. Okay? So you can solve it at any of these methods and the answer should be the same, but the answer will be 1, and which is option A. Okay? Next question. If x to the power a by x to the power b whole to the power a square plus ab plus b square into x to the power b by x to the power c into b square plus bc plus c square into x to the power c by x to the power a whole to the power c square plus ca plus a square. So this is a very similar question which we've done earlier, but it's just a proof to what I told you all, that the formulas will not be written. We'll not solve this on paper, we'll just solve this mentally because we've already done such a question. So in the first step, what do you get? X to the power a by x to the power b can be written as x to the power a minus b, and that is whole into a square plus ab plus b square, right? So what is the formula of a minus b into a square plus ab plus b square, which is a cube minus b cube. So the first term can be written as x to the power a cube minus b cube. The second term can be written as x to the power b cube minus c cube, and the third term can be written as x to the power c cube minus a cube, right? So all you need to do is again apply the same formula. X to the power a into x to the power b into x to the power c is equal to x to the power a plus b plus c. Just apply the formula and you will get the answer. Yet if you want me to just solve this, I'll just do it in a very simple step. So let's write this. So we'll write this in very simple terms. The first term can be written as x to the power a minus b whole to the power a square plus ab plus b square. The second term can be written as x to the power b minus c into b square plus bc plus c square. And third term can be written as x to the power c minus a into c square plus ca plus a square. Okay. So why? This is because x to the power a by x to the power b is equal to x to the power a minus b. Okay. We'll remember this, a minus b into a square plus ab plus b square is equal to a cube minus b cube. So this will be x to the power a cube minus b cube. This will be x to the power b cube minus c cube. This will be x to the power c cube minus a cube. So this can be written as x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. Okay, we'll cancel. So this becomes x to the power 0, which is equal to 1, which is option A, and this is the answer. initially I have taken a lot of pain to tell you all that a square plus ab plus b square can be written as a cube minus b cube by a minus b. That was because we were going through a concept formula. But when it comes to the exam hall, you can just simply write this as mentally solve it as a cube, a minus b into this. This would give me a cube minus b cube, and then just add. Okay. Let's move on to the next question. MCQ 35. If 2 to the power x is equal to 3 to the power y is equal to 6 to the power minus z, find the value of 1 by x plus 1 by y plus 1 by z. Okay? Got the question? Now, let's just give it a normal random approach by indices itself, and again we'll take it by logarithms also. So let 2 to the power x is equal to 3 to the power y is equal to 6 to the power minus z be equal to k. Okay. So what we can state is 2 to the power x is equal to k, right? If I take the 1 by xth power on both the sides, so what do I get? I get 2 to the power x into 1 by x is equal to k to the power 1 by x. I'm just taking root over of xth power on both sides. So this can be written as 2 is equal to k to the power 1 by x. Similarly, 3 to the power y is equal to k. Again I'll take root over of yth power on both the sides. So I'll get 3 to the power y into 1 by y is equal to k to the power 1 by y. Or this can be written as 3 is equal to k to the power 1 by y. Agreed? So you've got two values. 2 is equal to k to the power 1 by x and 3 is equal to k to the power 1 by y. Right? Now we need to find the value of 6 to the power minus z. So 6 can be written as 2 into 3 to the power minus z. Or in place of 2 we just found out it is k to the power 1 by x into 3 could be written as k to the power 1 by y whole to the power minus z. So this can be written as k to the power 1 by x plus 1 by y, right? Because a to the power x to the power a into x to the power b is equal to x to the power a plus b. Agreed? So this can be written as k to the power 1 by x plus 1 by y whole to the power minus z. Agreed? Right? Now if you notice that we already took 6 to the power minus z is equal to k, because our first step stated that let 2 to the power x is equal to 3 to the power y is equal to 6 to the power minus z is equal to k. So therefore the value of 6 to the power minus z is equal to, so value of this is equal to k. So I'm just substituting this. I'm just writing that k is equal to k to the power 1 by x plus 1 by y whole to the power minus z. Agreed? Right? Now if I take the root over of zth power on both the sides, so what will I be left with? K to the power 1 by z is equal to k to the power 1 by x plus 1 by y whole to the power minus 1. Right? I'll just write this step again. What it states is, what we got is k to the power 1 is equal to k to the power 1 by x plus 1 by y whole to the power minus z. Right? So what I'm doing is, I'm just taking the zth power on both the sides. So what will I get is k to the power 1 by z is equal to k to the power 1 by x plus 1 by y whole to the power minus z into 1 by z. So this can be written as k to the power 1 by z is equal to k to the power minus 1 by x minus 1 by y. Right? I'm just multiplying the minus 1 into 1 by x and 1 by y. So since we did study that if x to the power a is equal to x to the power b, then a is equal to b, right? That is, if both the bases are same and both the equations are equated, then both the powers are also equal. So therefore 1 by z is equal to minus 1 by x minus 1 by y. Agreed? we'll just take this 1 by z plus 1 by x plus 1 by y is equal to 0. I'm just taking this on this side. So the value which was required to be found out is 1 by x plus 1 by y plus 1 by z. As you can see, this is coming to 1 by x plus 1 by y plus 1 by z is equal to 0. So this is our answer, which is option B. So the answer states, answer stands as 0, option B. Okay, we'll solve this by log also, so that it's always helpful to you, because I am very sure that many people are going to approach this by log only, because the first thing which comes to our mind when we see questions like this is log. So that you can understand the particular method, we'll solve this by log also. So the question states, again we'll take it as k only. So let 2 to the power x is equal to 3 to the power y is equal to 6 to the power minus z is equal to k. So let's just take the first part first. So it says 2 to the power x is equal to k. We'll take log on both sides. So what do we get? X log 2 is equal to log k. Agreed? So the value of x is equal to log k by log 2. Similarly, the value of y is equal to log k by log 3. For z, we'll find out. It says 6 to the power minus z is equal to k. Taking log on both sides, so we get minus z log 6 is equal to log k. So therefore, minus z is equal to log k by log 6, or z is equal to minus log k by log 6. Right? Agreed? Now, we have to find out the value of what? 1 by x plus 1 by y plus 1 by z. Right? Let's substitute. In place of x, we'll substitute what? 1 by x is what? Log k by log 2. So 1 by x will be log 2 by log k. In place of y, we'll write log 3 by log k. And in place of z, we'll write minus log 6 by log k. Agreed? So this can be written as what? We'll take log k as the LCM. So what do we get? Log 2 plus log 3 minus log 6 by log k. So log 2 plus log a plus log b is equal to log ab. Right? Log ab is equal to log a plus log b. So log 2 plus log 2 plus log 3 can be written as what? Log 6. Right? Because log ab is equal to log a plus log b minus log 6 by log k. So this gets cancelled. So this is equal to 0, answer, which is option B. Correct? I solved it by both the methods. Whichever is preferable to you, whichever you understand, whichever strikes you first instead in the exam, that is exactly the correct method which you should always take to. Okay? And the answer stands as 0. Let's take the next question. MCQ 36. Show that, okay, the question is wrong, not show that. It says find out the value of x to the power 1 by a minus b whole to the power 1 by a minus c into x to the power 1 by b minus c whole to the power 1 by b minus a into x to the power 1 by c minus a whole to the power 1 by c minus d. It may look complicated, but it's very simple. Let's solve this on paper. So the question states x to the power 1 by a minus b whole to the power 1 by, see, the question is what? X to the power 1 by a minus b whole to the power 1 by a minus c into x to the power 1 by b minus c whole to the power 1 by b minus a into x to the power 1 by c minus a whole to the power 1 by c minus b. Agreed? This is the question. Let's just multiply and get this into a simpler form. So this can be written as x to the power 1 by a minus b into a minus c. Right? Now, this can be written as x to the power 1 by b minus c into b minus a. And this can be written as x to the power 1 by c minus a into c minus b. Right? Now, the first thing which strikes us is that if we have something like x to the power a into x to the power b into x to the power c, so the simplest thing which we will write is x that is equal to x to the power a plus b plus c. Right? Our first indices formula, x to the power a into x to the power b is equal to x to the power a plus b. So let's write this into the simplest form. This can be written as this is equal to x to the power 1 by a minus b into a minus c plus 1 by b minus c into b minus a plus 1 by c minus a into c minus b. Now all people who have a lot of problem with minus, plus and sign problem, so the simplest thing which I would advise is take 2 steps but please pay attention to accuracy. Okay, so we have a minus b, so let's keep this also as a minus b, right? So in order to keep this as a minus b, this would be multiplied with minus, so this would become minus, right? And then you can write this as a minus b. Agreed? Now the next thing which you have is a minus c. Here you have c minus a, right? So again we have to change this also. So in order to make this as a minus c, what you have to do is you have to again put this as minus, and then this can become a minus c, right? Then another thing is you have b minus c. So in order to change this also into b minus c, you have to make this as plus, right? Because the sign has to again be changed, so it will become plus. So then this will become b minus c. This is what you have to solve mentally. I cannot write 3 steps, right? So after this, we'll just boil down to whatever we've come to. So we wrote this as x to the power 1 by a minus b into a minus c, right? We stayed with the minus here, so 1 minus 1 by b minus c into a minus b. So this became plus. So plus 1 by a minus c into b minus c. Agreed? So now we have all in the same form. See, a minus b, a minus b, a minus c, a minus c, b minus c, b minus c. Right? I'll just take another minute to explain this. What happens is, here you have 1 by a minus b. So let's find out whether other terms are also a minus in the form of a minus b only. So here we had b minus a, right? So in order to make this as a minus b, you have to take minus common. So again this plus would become minus, right? So here we changed it. Similarly for a minus c, here we have c minus a. So again to make this into a minus c, we got a minus, right? Then we had b minus c. So again to get this as b minus c, we have to again get a minus common. So this minus became plus, right? This can always be solved mentally also. Now, so finally what we've come to is the power 1 by a minus b into a minus c plus 1 by b minus c into a minus b plus 1 by a minus c into b minus c. So now let's just take the LCM. See, what would be the LCM? A minus b into a minus c, a minus c into b minus c. Agreed? So here what is missing in the first one is b minus c. So b minus c. In the second one b minus c, a minus b, so a minus c plus a minus c plus a minus c, b minus c, so you get a minus b. Agreed? Okay, so here we, okay, I just copied something wrong. Here it is minus, right? So this will be minus a and this will be plus c. Okay? Now let's just cancel. Plus c, minus a plus b minus b. Okay? So this is x to the power 0 by a minus b into a minus c into b minus c. Right? So this is obviously x to the power 0. What is the value of x to the power 0? Anything to the power 0 is 1. So the answer is 1, which is option A. Correct? Right? MCQ 37. Show that a plus bth root of x to the power a square by x to the power b square into b plus cth root of x to the power b square by x to the power c square into c plus ath root of x to the power c square by x to the power a square would reduce to what? The question is very simple. It's just this that it looks complicated. Let's solve it. So the question is a plus b x to the power a square by x to the power b square into b plus c root over of x to the power b square by x to the power c square into c plus a root over of x to the power c square by x to the power a square. Okay? Now, see, the first thing which strikes us is that if we have something like a plus b outside and this is x to the power a square by x to the power b square. Anyways, we know if we have something like x to the power a into x to the power b, the first thing which will strike us is x to the power a plus b. Similarly, here we have something in the form of x to the power a by x to the power b. So the first thing which we need to do is write this as x to the power a minus b. So this can be written as x to the power a square minus b square. Agreed? This is whole to the power what? 1 by a plus b. Right? I'm sure you all know that if we have something like root over of x, so it can be written as x to the power half. Right? So the second part could be written as x to the power b square minus c square whole to the power 1 by b plus c. Similarly, we can write this as x to the power c square minus a square whole to the power 1 by c plus a. Right? Now, this, we'll just open the thing which we know, the very common algebra formula, a square minus b square is equal to a plus b into a minus b. So this can be written as x to the power a plus b into a minus b whole to the power 1 by a plus b into x to the power b plus c into b minus c whole to the power 1 by b plus c into x to the power c plus a into c minus a whole to the power 1 by c plus a. Okay? So, this gets cancelled, this and this gets cancelled, and this and this gets cancelled. So, we are just cancelling, suppose if we had multiplied it and then things would have got cancelled. So, we are left with x to the power a minus b into x to the power b minus c into x to the power c minus a. Right? Again, the same thing which I always told you, which should strike is, if we have something like x to the power a into x to the power b, this would be equal to x to the power a plus b. So here this would be equal to x to the power this plus this plus this. cancel, CC cancel, AA cancel, so you're left with x to the power 0, which is equal to 1, which is the answer. So that is option A. Okay? Let's move on to the next question. MCQ 38. The question says, show that x to the power b plus c by c minus a whole to the power 1 by a minus b into x to the power c plus a by a minus b whole to the power 1 by b minus c into x to the power a plus b by b minus c whole to the power 1 by c minus a would reduce to what? Okay? Let's solve this. So the question is, x to the power b plus c by c minus a whole to the power 1 by a minus b into x to the power c plus a by a minus b whole to the power 1 by b minus c into x to the power a plus b by b minus c whole to the power 1 by c minus a. You have to find out the value of this, right? So this can be written as x to the power b plus c by c minus a into a minus b plus, I am applying the same thing again, x to the power a into x to the power b is equal to x to the power a plus b. So this can be written as plus c plus a by a minus b into b minus c plus a plus b by b minus c into c minus a. Agreed? Right? So now let's take the LCM. The LCM would be c minus a into a minus b into b minus c. Very good. The question is no plus minus problems here. Everything is the same. We have c minus a, we have c minus a, we have a minus b, we have a minus b, we have b minus c, we have b minus c. So nothing which needs to be changed. So in the first part, it would come to b plus c into b minus c plus c plus a into c minus a plus a plus b into a minus b. Right? I hope you can understand. What is missing here is b minus c. So multiply by b minus c. Similarly, your c plus a and your a plus b. Now, I hope you are very well aware now by all algebraic formulas. So b plus c into b minus c is equal to b square minus c square. So this can be written as b square minus c square. C plus a into c minus a can be written as c square minus a square. A plus b into a minus b can be written as a square minus b square divided by c minus a into a minus b into b minus c. Right? Let's start cancelling. Plus c square minus c square plus b square minus b square plus a square minus a square. So this can be written as x to the power 0 by c minus a into a minus b into b minus c, which is equal to x to the power 0. I am very sure all of you are aware that 0 by something is 0 and anything by 0 is infinity. Very good. So x to the power 0, which is equal to 1, and which is option A. Right? So the answer stands as option A, and the answer is 1. Correct? Agreed? Very simple. Whenever you have such questions, don't get so tensed. It's very simple. just multiply. Always remember, the only thing in any complication will have the very general formula. X to the power AB is equal to x to the power x to the power A into x to the power B is equal to x to the power A plus B. Very similar to what we have with logarithms. Log AB is equal to log A plus log B. Okay, so these two formulas, if you remember, I'm sure you will make it through. Okay, let's move on to the next question. Next question, MCQ 39. 1 by x to the power B plus x to the power minus C plus 1 plus 1 by x to the power C plus x to the power minus A plus 1 plus 1 by x to the power A plus x to the power minus B plus 1 would reduce to 1 if A plus B plus C is given by. So when we have such questions, you can have two ways to solve this because it's going to be very complicated if you try and solve the same question, and obviously you will not have that much of time in the exam. So what you can do is, either you can like apply when this would reduce to 1, or you can just evaluate the options. So here you have something like if A plus B plus C is given by. So either you can have trial and error method and solve by taking A plus B plus C as 1 or 0 or minus 1, and then find out when is this actually reducing to 1. So that is one way of doing the question. Or second way could be that you could just understand that when would this reduce to 1. This can reduce to 1 in one circumstance. I mean, there can be various circumstances, but one of them could be that the first part, that is 1 by x to the power B plus x to the power C plus 1 would come as 1. 1 plus x to the power C plus x to the power minus A plus 1 would again be 1. So that comes 1 plus 1, 2. So the third part automatically has to be 1, and only then this particular equation would reduce to 1. So these three values, putting 1 plus x to the power B plus x to the power minus C plus 1 as 1, the second part also as 1, and the third part as minus 1, we could find out that what is the value of A plus B plus C. That is one way of solving the question. The second way could be, you could take A plus B plus C as any of these options and then evaluate and see which one comes out to be the correct answer. So if you were given an option to choose among the options, so then A plus B plus C equal to 1 is not a preferable choice, because whatever value you want to put, like suppose if you take A plus B plus C is equal to 1. So suppose you have to like reduce this, so then obviously A would be equal to 1 minus B minus C, which sounds very complicated compared to what could happen is, if you had taken A plus B plus C as 0, then A would be just equal to minus B minus C, which would be a very easier way to solve the problem, because at least one term is getting reduced and it would be easier to put values. So your preferable choice would always be taking A plus B plus C as 0 instead of 1 or minus 1. These are some tips which you should actually give it a minute thought before starting, solving a question, so that at least you don't waste a lot of time. And suppose if anyone's thinking of solving this particular equation only, I'm sure it will take 3 or 4 pages, and then only you will get the answer, which is not what CPT requires. So you should actually try and solve this smartly. Either take what I told you, the first option, take both the first part and the second part as 1, 1 and the third part as minus 1, and then find out the value of A plus B plus C, or you could evaluate the options. Okay, so we'll solve by both the methods. Let's start with the first method first. So let's solve it by the first method first. So the first part, that is 1 by x to the power B plus x to the power minus C plus 1 is equal to 1. We are normally cross multiplying. 1 is equal to x to the power B plus x to the power minus C plus 1. 1 and 1 gets cancelled. So, or we can write 0 is equal to x to the power B plus x to the power minus C. Right? Or we can write 0 is equal to x to the power B plus 1 by x to the power C. Or I'm just taking the LCM, x to the power C So this will be written as x to the power b into x to the power c, that is x to the power b plus c plus 1 is equal to 0. This can be cross multiplied. So this will come 0. So x to the power b plus c plus 1 is equal to 0. Okay. So or x to the power b plus c is equal to minus 1. So we'll remember that x to the power b plus c is equal to x to the power b plus c is equal to minus 1. Okay. Just remember this. I'm sure we'll get something to equate. Now let's solve the second part. So the second part is 1 by x to the power c plus 1 by x to the power c plus x to the power minus a plus 1 is equal to 1. Right? That is what we had thought that we'll assume. Or again the same cross multiplication, 1 is equal to x to the power c plus x to the power minus a plus 1. Okay. Or we can write 1 and 1 goes cancelled and you're left with x to the power c plus 1 by x to the power a is equal to 0. Or again we can write this as x to the power c into x to the power a, which would be x to the power a plus c plus 1 by x to the power a is equal to 0. So again we will cross multiply, or x to the power a plus c plus 1 is equal to 0. Or you can write x to the power a plus c is equal to minus 1. Right? So previously what we got was that x to the power a plus c is equal, x to the power b plus c is equal to minus 1. Now we've got x to the power a plus c is equal to minus 1. So by both of these we can write that x to the power a plus c is equal to x to the power b plus c. So if both bases are equal, then the powers also have to be equal. So a to the power c is equal to b to the power c. Or you can write a is equal to b. Agreed? Right? So we'll remember this, and now let's move on to the third part. The third part is that 1 by x to the power a plus x to the power minus b plus 1. Okay. So what this, again this would be equal to what? Minus 1. If you remember, that is what we had taken. Right? That if the first two parts are 1 and 1, so the entire equation to reduce to 1, the third part has to be minus 1. So what this can be written as 1 is equal to minus x to the power a minus x to the power minus b minus 1. Right? Or 2 is equal to, minus 2 is equal to x to the power a plus x to the power minus b. Or we can write this as minus 2 is equal to x to the power a plus 1 by x to the power b. Or minus 2 is equal to x to the power a plus b plus 1, cross multiplying, so this will become x to the power b. Agree to this? Right? Yeah. So a is equal to b. So or we can write minus 2 x to the power b is equal to x to the power, instead of a I'm putting b. So we get 2b plus 1. Let's write this equation. This equation comes to, in a proper form, this equation comes to x to the power 2b plus 2x to the power b plus 1 is equal to 0. Agreed? If you can see, this is actually equal to x to the power b plus 1 whole square. Or this can be written as x to the power b plus 1 is equal to 0. Or x to the power b is equal to minus 1. Agreed? Right? Again, since a is equal to b, so therefore we can write x to the power a is also equal to minus 1. So we have two values, x to the power a is equal to minus 1 and x to the power b is equal to minus 1. Right? Now let's see what we had got previously. In one of these equations, we need to substitute so that we can get the value of c. So we had got one equation which stated x to the power a plus c is equal to minus 1. Okay, this we had got. So or this can be written as x to the power a into x to the power c is equal to minus 1. X to the power a's value is minus 1 into x to the power c is equal to minus 1. So therefore the value of x to the power c is equal to 1. Right? So we have 3 values now. What are the 3 values? We can say x to the power b is equal to minus 1, x to the power a is equal to minus 1, x to the power c is equal to 1. Now we will just write a small thing. We know that x to the power a into x to the power b into x to the power c is equal to x to the power a plus b plus c. We know that the value of x to the power a we got is minus 1 into x to the power b is minus 1 into x to the power c is 1. This is equal to x to the power a plus b plus c. So this is coming to 1 is equal to x to the power a plus b plus c. Agreed? Or x to the power 0 is equal to x to the power a plus b plus c. So therefore a plus b plus c is equal to 0, which is our answer. Okay? So now I hope it's clear. This was one method. The another method which you can take is just take a plus b plus c as 0. Assume, take in the first equation, substitute b in the form of a and c, and then you can solve it by normal the way how we've solved this, and you'll again get this as 1. So then you'll know that the option a plus b plus c is equal to 0 is the correct answer. So now let's move on to the next question, MCQ 40. On simplification, 1 by 1 plus z to the power a minus b plus z to the power a minus c. There's a plus missing. So plus 1 by 1 plus z to the power b minus c plus z to the power b minus a plus 1 by 1 plus z to the power c minus a plus z to the power c minus b would reduce to what? This is the question, and it's simple. It just looks complicated. Let's solve this. We will solve the first part. The first part is 1 by 1 plus z to the power a minus b plus z to the power a minus c. See, whenever you see something like a 1 here, the first thing which should strike is this can be written as z to the power a minus a, right? Because that is the simplest way to solve. So this can be written as 1 by z to the power a minus a plus z to the power a minus b plus z to the power a minus c. This would be equal to 1 by, I'm just writing, you know, x to the power a minus b is equal to x to the power a by x to the power b. So this can be written as z to the power a by z to the power a plus z to the power a by z to the power b plus z to the power a by z to the power c. Correct? Let's take z to the power a common. So we are left with 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c. Agreed? Right? Now let's solve the second part. The second part is 1 by 1 plus z to the power b minus c plus z to the power b minus a. Right? So again we will substitute 1 by 1 as z to the power b minus b plus z to the power b minus c plus z to the power b minus a. Okay? So this can be written as 1 by z to the power b by z to the power b plus z to the power b by z to the power c plus z to the power b by z to the power a. This is equal to 1 by, take z to the power b common, so you are left with 1 by z to the power b plus 1 by z to the power c plus 1 by z to the power a. Correct? Right? Similarly, for the third part, you will get this is equal to 1, I'm just writing this. Okay, for the third part, you're going to get, solve it in a very similar way. You'll get 1 by z to the power c common, and you'll be left with 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c. Okay? So if I write all these 3 equations clubbed, so what do I get? I write all these 3 equations together. This is 1 by z to the power a into 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c plus 1 by z to the power b into 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c plus 1 by z to the power c into 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c. Okay. Now just see this step properly. Okay. I'm just taking 1 divided by, I'm just taking whole, whatever I'm taking common is 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c. Okay. So what am I left with? 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c. It's a little confusing, so let's just check out whether we've done the correct thing or not. Let's multiply this term and this term. So what will I get? 1 by z to the power a into 1 by z to the power a plus 1 by z to the power b plus 1 by z to the power c, which is this term, right? So this way you can just check. So you got this as the numerator, this as the denominator, both gets cancelled and the answer comes as 1, which is the answer. Okay, so the answer is option C, 1. Okay, can we move on to the next question? Yes, so let's start. The question says, on simplification, x to the power ab by x to the power a square plus b square whole to the power a plus b into x to the power b square plus c square by x to the power bc whole to the power b plus c into x to the power ca by x to the power c square plus a square whole to the power ca reduces to. This question looks simple. Let's solve. So let's simplify this. If you remember, x to the power a by x to the power b is equal to x to the power a minus b. So applying this, we can write that. We can write the first part as x to the power ab minus a square minus b square whole to the power a plus b into x to the power b square plus c square minus bc whole to the power b plus c into x to the power ca minus c square minus a square whole to the power c plus a. Okay. So this is minus c square minus a square whole to the power c minus a. Okay. I'll just write this step again. This comes to what? X to the power ab minus a square minus b square whole into a plus b into x to the power b square plus c square minus bc whole into b plus c into x to the power ca minus c square minus a square into c plus a. Okay. Now please see this. I wrote this step just again so that you can see a similarity and compare this to some algebraic formula that you are aware of. If you remember, a cube plus b cube is equal to a plus b whole into a square plus b square minus ab. So, seeing this, you can see that we have a plus b, we have a square plus b square, if we take minus common, minus ab, right? So, this formula can be applied. So, we can write this as x to the power, if we've taken minus common, so we'll get a cube plus b cube. So, a cube plus b cube. Similarly, for this we don't need to take minus common. We have it in the simplest form. So, this can be written as b cube plus c cube. Okay. Into x to the power. Again, we'll have to take minus common here. So, then we'll get minus c cube plus a cube. Okay. Now, we know that x to the power a into x to the power b into x to the power c is equal to x to the power a plus b plus c. So we'll apply that, and this can be written as x to the power minus a cube minus b cube plus b cube plus c cube minus c cube minus a cube. Plus b cube minus b cube gets cancelled. Plus c cube minus c cube gets cancelled. We are left with minus 2a cube. Do we have that as an option? Yeah. That is option A, which is the answer. Okay. See, people who are always they want to complete things fast. I'm sure you're going to face a problem in these kind of questions. Even though in this question you don't have an option like 0 or 1, but I'm sure if we had an option like 0 or 1, there would be at least a bare minimum of 50% people who would have marked a 1. Because when things get cancelled like this, we mostly don't tend to notice that a cube and a cube is not getting cancelled. We would have cancelled that also and got a 0, and x to the power 0 would be equal to 1. So don't always assume that the answer would be 0 or 1 and not solve the questions, because accuracy matters a lot. You will miss out on a 0.25 also along with a question mark. So for that sake, I would always advise, please solve the question with a lot of accuracy, even if it takes a second more. Don't get in a hurry and just cancel. Okay. So the answer is x to the power minus 2a cube, which is option A. Okay. Let's move on to the next question. Next question, MCQ 42. The value of 1 by 1 plus a to the power y minus x plus 1 by 1 plus a to the power x minus y is given by. This is simple. Let's solve. 1 by 1 plus a to the power y minus x plus 1 by 1 plus a to the power x minus y. So as we see something like a to the power y minus x, obviously we know x to the power a by x to the power b is equal to x to the power a minus b. So we write this also as a to the power y by a to the power x plus 1 by 1 plus a to the power x by a to the power y. Let's take the LCM. So you're left with a to the power x plus a to the power y plus 1 by a to the power y, a to the power y plus a to the power x. Correct? Till now everything is okay? Yeah. So it just gets, this goes to the numerator. So you're left with a to the power x by a to the power x plus a to the power y plus a to the power y by a to the power y plus a to the power x. So what we've got is a to the power x by a to the power x plus a to the power y plus a to the power y by a to the power x plus a to the power y. Again we take an LCM, a to the power x plus a to the power y. So what will you get? A to the power x plus a to the power y. Both numerator and denominator is the same, so they get cancelled. This is equal to 1, which is option C. Right? So that's the answer. Okay? Right? We can move on to the next question. Next question, MCQ 43. If 2 to the power a is equal to 3 to the power b is equal to 6 to the power minus c, then find out the value of 1 by a plus 1 by b plus 1 by c. If you remember, we've already done this question, and I think we got the answer as 0. So simply we have done the question. You could take this is equal to k and just substitute in place of a, b and c, or in the second way around you can write 6 as 2 into 3. In place of 2 you can put the value in place of 3 and you will get 1 by a plus 1 by b plus 1 by c. We've done a similar question, so we will not solve this again. So the answer will be 43A0. Okay? We move on to the next question. The next question reads as follows. MCQ 44. if a to the power p is equal to b to the power q is equal to c to the power r is equal to d to the power s and ab is equal to cd, then find out the value of 1 by p plus 1 by q plus 1 by r, minus 1 by r minus 1 by s. So that's the question. Easy. Let's solve this. Let a to the power p is equal to b to the power q is equal to c to the power r is equal to d to the power s be equal to k. Okay? We always do this whenever we have some 3 or 4 equations. We always tend to take this equal to k. So let's just take the first part. It says a to the power p is equal to k. I take the root over of p at power on both sides. So I'm left with a to the power p by p is equal to k to the power 1 by p. Or a is equal to k to the power 1 by p. Agreed? Second part, b to the power q is equal to k. Similarly, we take the root over of q at power on both sides. So I'm left with b is equal to k to the power q. Similarly, this is 1 by q. Similarly, c is equal to k to the power 1 by r and d is equal to k to the power 1 by s. Okay? So here c to the power r is equal to k and here d to the power s is equal to k. This would lead to this, this would lead to this, this would lead to this. Okay? Now we have another thing in the question which states that AB is equal to CD. So let's just substitute the values. In place of A we can write k to the power 1 by p. In place of B we can write k to the power 1 by q is equal to, in place of C we get k to the power 1 by r. In place of D we get k to the power 1 by s. Okay? Right? We know that x to the power a into x to the power b is equal to x to the power a plus b. So, or this is equal to k to the power 1 by p plus 1 by q, which is equal to k to the power 1 by r plus 1 by s. Right? So, what we got is k to the power 1 by p plus 1 by q is equal to k to the power 1 by r plus 1 by s. We are very well aware that if two equations are equal and both the bases are same, so automatically it leads to the equality of the powers also. So therefore 1 by p plus 1 by q is equal to 1 by r plus 1 by s. Correct? I'm not writing, huh? Okay, I'll write. Since if x to the power a is equal to x to the power b, then a is equal to b. Agreed? We'll just bring this into a simplified form, or 1 by p plus 1 by q minus 1 by r minus 1 by s is equal to 0. The question told us to find out the value of 1 by p plus 1 by q minus 1 by r minus 1 by s. And that is what we found out, which comes to 0, and that is option C. So the answer stands as 0, option C. Okay? Without even knowing anything, if you would have just solved the question, you are getting the correct answer. Okay? Let's move on. MCQ 45. If x is equal to, it's written twice. If x is equal to root over of 3 plus 1 by root over of 3 and y is equal to root over of 3 minus 1 by root 3, find out the value of x square minus y square. Now, see, the only thing why this question has probably been put in is, the first thing which would, strike a normal mind when you're just used to working without smartly, you would have done what? You would have put in the place of x root 3 plus 1 by root 3, found out the square which is a plus b whole square, and then lead to complication. But if you know that there is something like x square minus y square, you know the formula, it's x plus y into x minus y. So in place of x plus y, just we know that if we have x plus y, so we would get root 3 plus 1 by root 3 plus root 3 minus 1 by root 3. So plus 1 by root 3 minus 1 by root 3 gets cancelled. So we're getting 2 root 3, right? And the other part would be x minus y. So that will be root 3 plus 1 by root 3 minus root 3 plus 1 by root 3. So root 3 and root 3 would get cancelled. So here we have 2 root 3, right? 2 by root 3. So both get multiplied. So root 3 and root 3 gets cancelled. So you're left with 2 into 2, 4. So the answer would be D, 4. That you could have always solved it mentally, but we'll solve it on paper also. Yeah. So the question is, we are required to find out the value of what? X square minus y square. So this is equal to x plus y into x minus y, right? In place of x, what can we write? Root 3 plus 1 by root 3 plus root 3 minus 1 by root 3, right? And in place of x minus y, what can we write? Root 3 plus 1 by root 3 minus root 3 plus 1 by root 3, right? So these two get cancelled, here these two get cancelled. So here we get 2 root 3 into, in place of this we get 2 by root 3. Root 3 gets cancelled. This is equal to 4. That's option D is the answer. Correct? Very simple question. Next question, MCQ 46. If A is equal to root over of 7 minus 4 root 3 by 7. Okay, I think the numerator has 7 plus 4 root 3. The denominator is 7 minus 4 root 3. Then find out the value of A into A minus 14 whole square. Okay. Simple. Just maybe a root is putting you into a little bit of confusion, but it's going to be simple. If we have such questions, I'm sure whenever there's something like a root or something, the first thing which strikes us is a rationalization. So let's rationalize and see what it's coming to. The value of A is equal to root over of 7 plus 4 root 3 by 7 minus 4 root 3. Right? This is given to us. Right? So first let's rationalize. So this is equal to 7 plus 4 root 3 by 7 minus 4 root 3. The denominator is always rationalized. So 7 plus 4 root 3 into 7 plus 4 root 3. Agreed? So this would be actually equal to what? 7 plus 4 root 3 whole square. See, please make sure you don't start solving it as a plus b whole square and all that, because you know there's a root outside. So if you are aware that there's a root, obviously the square will get cancelled. So don't solve it. And in this place, we know that a square minus b square is equal to a plus b into a minus b. So this is in that form. So a square would be 49 minus b square would be 4 4s are 16 and 3. 16 into 3, 48. So 49 minus 48, which is 1. So this and this square gets cancelled with the root. So we would be left with 7 plus 4 root 3. So the value of A is 7 plus 4 root 3. Agreed? Now we are required to find out the value of what? We are required to find out the value of A into A minus 14 whole square, right? So this can be written as A square minus 14A whole square, right? Now in place of A, what do we know? The value is of 7 plus 4 root 3, right? So A's value is 7 plus 4 root 3. So A square would be equal to what? This will be 7. Okay, we can just, anyways, I think we can miss out on a step. If we remove this, let's just put the value of A. This is 7 plus 4 root 3, right? and a minus 14 would be 7 plus 4 root 3 minus 14, right, whole square. So this would be equal to 7 plus 4 root 3 into minus 14 plus 7, so we're left with minus 7. So 4 root 3 minus 7 whole square. So this is again in the form of a plus b into a minus b, right? It will be simpler, otherwise you'll have to open a square plus ab plus b square, 2ab plus b square. So this is a minus b and a plus b. So this is a square minus b square. So what is a here? 4 root 3. So a square would be 4 4 is 16, 16 to 3, 48. So 48, and what is b square? 49 whole square, right? 48 minus 49 is minus 1. So this whole square, this would be equal to 1, and this is the answer. I have also tried and solved this as a student itself very genuinely, because the first thing which would have struck me when I saw a into a minus 14 would be a square minus 14a. But as soon as I realized that there is a minus 14 and there is a plus 7, I can again get the same value. So obviously I would probably not want to get into complications, and that's why we'll apply the formula a square minus b square. Okay. So that was all from ratio and proportions, and all I can tell you all is just go through all these additional questions, solve them. We almost tried and solved every question, every type of question which we could, and hoping that you all will be able to solve the question whichever is there in the examination. Don't get panic. I am always sure that you can, if you just solve it, put a pen on paper, I'm sure you will be able to. Just remember, in case you are just not able to solve the question, try evaluating the options always, and you will be able to. And that should instead be your first priority in all these MCQ examinations which you have, these objective examinations. Try and first evaluate the options. If the options itself gives you a very apparent answer, please try not using the paper. And this is not only for ratio and proportion. I would advise you all for every chapter, try solving as much as you can without using a pen and paper. Get into the habit and you will do very well. All the best for your exam, and hope you all do well. Thank you for watching the video, and that's all for the day.